So in today's lecture, we are going to discuss about ARP protocol. As everyone knows that ARP stands for Address Resolution Protocol, and it is an important protocol that plays an important role in the networking world. When working with your network systems, this protocol, ARP protocol, helps you to identify specified network devices and find their addresses. This all thing we have already discussed in our previous lecture. So it is a network. What we can say is it is a networking protocol used to determine the MAC address, hardware address, or you can say physical address from any IP address. In our initial lectures, we have discussed the basics about the ARP protocol. In today's lecture, we are going to discuss in detail. So I can say that when one device want to communicate to another device in a LAN network, ARP protocol is useful. Using ARP protocol, this is possible. So I can also say that ARP is used to map the IP address into MAC address. Now we are going to understand how the ARP protocol works using this scenario where I have put this on the board, that there is a switch and two PCs are connected. PC1 and PC2 are connected. But before moving ahead and discussing about the ARP protocol in detail, we will understand some terms and terminologies used to for this ARP protocol process to complete. So everyone is ready? Please confirm in the chat box. So there are some terms and terminologies that we have to understand, that we will be uh, hearing about these terms and terminologies when we will understand this ARP protocol, how it works. So there is something called ARP cache. Now, just for some time, understand that PC1 has already communicated to PC2. PC1 knows the MAC address of PC2. You know what will happen? Once the communication is established, meaning that PC1 knows the MAC address of PC2, right? Right or wrong? So, what PC1 will do, once the address is being received, the MAC address is learned from PC1 to PC2, it will be storing it. The PC1 will store that MAC address. Whichever MAC address PC1 has learned, it will store it. Where it will store? In a temporary storage. And the mapping will be done between the IP address and the corresponding MAC address. The PC1 will have the local storage, that is ARP cache, in it, and it will be showing the entries that this specific IP address is mapped to this MAC address, and these entries will be shown in your PC1 MAC table, which is nothing but a ARP cache. Now, when this device want to send the data to this, like if PC1 has already learned and this device want to send the data to PC2, it will first check its ARP cache. Is it clear? And these entries are dynamic. These cache entries are dynamic in nature, meaning that they will have a limited lifespan, and they will keep on flushing out at a specific interval. But if you do a manual entry, that will not go out. We have seen in the switch, right? We have added the MAC entry, and that doesn't wipe out. Similarly, over here, PC1 also will maintain the ARP cache, which is nothing but a local storage, a local table, a temporary table, and at a specific interval, it will wipe out because it is a dynamic entry. So, what is ARP cache? It is clear. Now, there will be another term called as ARP cache timeout. So, what is ARP cache timeout? It is nothing but a duration of which, like let's say for example, there was a communication established, PC1 has learned the PC2 MAC address. So now it is a dynamic entry, and since it is a dynamic entry, definitely it is going to have some specific time interval, and then that entry will be flush out. So the duration for which a device will store this mapping between the IP address and MAC address is nothing but a ARP cache timeout. Is it clear? Then another thing is ARP request. Now this PC1 want to communicate to PC2. It will broadcast the packet to know the MAC address of PC2. How it will broadcast that everything we will discuss in some time. So that is nothing but a ARP request, and when the PC2 will reply back is nothing but a ARP reply. Let's understand this in detail. But before that, we will see how to check these entries. Everyone, just open the command prompt in your PCs, okay, and give the command r minus a. You will see that the command will display a list of IP addresses and their corresponding MAC addresses that your computer has recently communicated over a local network. Everyone can see these entries in their PCs, and see the type is dynamic, which means that it will have a specific duration, right? Everyone is able to see this. So it okay. So here it is r dash a. This is the command. This is nothing but a r cache of your PC. Now, moving ahead with the discussion, how the ARP protocol works. Now, this is PC1. Let's say when a sender, that is a PC1, want to communicate with a receiver, in our case, which is PC2. As a sender, it will be a PC1, receiver will be a PC2 in our example. When a sender wants to communicate with a receiver, the sender will first check its ARP cache. Where is ARP cache? This is ARP cache. It's local entries. Where do I have the MAC address to which I'm going to communicate? Let's say, for example, you say that PC. This is PC1, right? This is PC1 having IP 192.168.1.10, and this is PC2 having IP address 192.168.1.20. The very first thing what PC1 is going to see is ARP cache table, whether I know I'm communicating to 192.168.1.20. Do I have the MAC address of this IP address? It will first check. Now, if the MAC address of the receiver device, which is PC2, is not present in ARP cache, it is not available with PC1, then in such a situation, you know what will happen? The ARP request message is prepared by the PC1, by the sender. And how is this address, how is this message prepared? We will see that. In this is how the message is prepared. There is some issue. Okay, anyway, if the ARP cache, PC1 checks its ARP cache and the entry is not available, it will start to prepare the ARP request message requesting the receiver to give the MAC address. Okay. So what it will contain, this message, what it will contain, source MAC, which is the sender MAC, PC1 MAC address. Okay. It will have the sender MAC address, which is nothing but a source MAC address. Then its own IP address. Okay, its own IP address, which is source IP, the IP address of the PC1. It is communicating to PC2, right? So it knows the destination IP address. So the third field will contain the IP address of the receiver, which is destination IP address. Now it doesn't know the MAC address, right? This field will be empty. This field will be empty because the destination MAC address is not known, and that's the reason the ARP protocol has come into the role, right? Now this message, this complete message is broadcasted over the LAN. This complete message is broadcasted over the LAN. PC1 broadcast, the broadcast come to switch, and everyone knows that switch switch has switch is broadcast device. Whatever comes on one port, switch will broadcast to all other ports. This we have discussed in the basics. In today's lecture we are going to discuss in detail about collision and broadcast in the coming time, but for now we have learned that how the switch works. Once it receives the frame on one port, broadcast to all other ports, right? Now, the sender device has broadcasted. The PC1 has broadcasted the ARP request. Which ARP request? This one, which contains source MAC, source IP, destination IP, and the MAC address of the destination is unknown. This is broadcasted. Because this is a broadcast message, every device connected on this switch will get this broadcast message. Now, if there are 100 pieces connected to this switch, all of them will get the broadcast message. But you know what will happen? Every Each and every devices will check the this broadcast message, which contains source MAC, source IP, destination IP, and they will check, okay, destination IP is this, so this is not for me, this broadcast is not for me, they will drop. Another PC will check this broadcast destination IP is this, okay, this is not for me, it will drop. But when it reaches to PC2, PC2 will check what is the destination IP in the frame. It will check, oh, this is 192.168.1.20, okay, this is for me. Now this PC will accept, PC2 will accept, and all other PCs in the network will drop the request message because this was not intended for them. Okay, the device whose IP address matches the receiver IP address, that is destination IP address of this message. Which message? This broadcast message, ARP reply message, ARP request message, will accept it. Now this PC will see, okay, fine, this request for was for me because the destination IP is matching with my IP address. Now it start to prepare the ARP reply. The ARP request is completed now. It reaches over here, the ARP request is completed. Now it will start to prepare the ARP response or a ARP reply. Remember, now over here the MAC address was not known, right? So it has broadcasted requesting for MAC address. But when this piece the message is received, this ARP request message is received to PC2, it has the source MAC address, it has a source IP, it has a destination IP, and it checks what it is requesting. It is requesting for my MAC address. Now it will start to prepare the response, and this response will again not be broadcasted. Now what will happen, I will tell you. Just 1 second. Okay, now this PC2 will start to prepare the ARP response, R reply, and when this will reply, it knows that where to send because it has a source IP, it has the IP address of the requester, it has the IP address, MAC address of the requester. So this PC2 will reply back, and this will be a unicast message. Remember, the ARP request is a broadcast message. It is a broadcast message. Why? Because the MAC address was unknown. Now, when the PC2 will reply to this request message, it will be unicast, means it will be one to one. Straight away, it will say that, okay, fine, I need to reply back, I need to respond back to the ARP request, and the destination over here will change. Now, what will happen? It will prepare the response, and while preparing the response, what is going to happen is this is how the response will be. While replying back, or else let's understand over here itself. Now over here, the source MAC address will be the MAC address of PC2. Okay, source IP will be the IP address of PC2. Destination IP the destination IP will be the IP of PC1, and destination MAC is also unknown from where it has come. It has to send over there. It will be PC1, and it will be the unicast message now. One-to-one message will be sent from PC2 to PC1, and in this way PC1 will come to know the MAC address of PC2. And remember, when this ARP request was received to PC2, at the same time PC2 will update its ARP cache. PC2 will update the entry saying that for 192.168.1.10, from this message it will take out the MAC address and it will store the entry. So now PC2 cache has the entry of PC1. PC1 cache, when receive the response from PC2, it updates its cache, and now PC1 also will have the MAC entry of PC2 in its ARP cache. Now the sender can receive and send data without any problem. Is this process clear to everyone? How the R protocol works? Is it clear to everyone? Any questions? Any doubt over here? Yes, Sarah. That we have already discussed. The switch also will make the entry of this MAC addresses. This we have discussed in our previous lecture, MAC learning on the switches, right? But again, we will discuss in coming time the MAC learning and aging in detail in advanced topic in advanced lab. Also, we are going to discuss as soon as the PC1 sends the request. Switch will check on which port it has received. So this all thing MAC learning we have discussed in our previous lecture, and it will update its MAC table. Similarly, from here also it will receive and it will update its MAC table. MAC learning was already discussed, but again today we are going to discuss in practicals. There are some different type of ARPs, that is proxy ARP. Then there is something called gratuitous ARP, reverse ARP. This we have to discuss, and this we will discuss in our practical. Just the first thing, proxy ARP, I will give you a short idea. Now we know that if there is any, let's say for example, instead of switch this was a router. Instead of switch this was a router. What is going to happen? What happen? Now PC1 want to know the MAC address of PC2 to communicate. PC1 will prepare the ARP request, that is a broadcast message. As soon as it is received on the router is does not broadcast, right? Router is not a broadcast device. This packet will get dropped because whatever receive on one port, the router doesn't broadcast on another port. This packet will get dropped. So there is something that this router will act as a proxy to learn the MAC address. How it will happen, this we will learn in the coming time, and we will be doing some practicals also about the proxy ARP and all. So this is something called proxy ARP. Then what is gratuitous ARP? What is reverse ARP? This all things we will discuss. Now again, we have already discussed about the collision and broadcast domain, but we will again learn because we will be starting about the VLANs and some important topics today. So let's discuss about something called collision domain, broadcast domain, and and the device's behavior. This everything we'll discuss in short, and then we will move ahead. Now, now let's discuss about collision domain and broadcast domain. Collision domain and broadcast domain in computer network. So the most common networking devices are hub, bridge, router, switches, right? The most common today we hear is routers and switches. most common are router and switches, but yes, the hubs and bridges used to be there before, right? We will understand why this devices got obsolete, why they are not used, but and this we will discuss in the practicals. Why these devices are no more used, what are the limitations and all we will discuss. But now coming to our topic, collision domain and broadcast domain. Now everyone open or let's do one thing. Let's understand straight away over here only, so that this topic will complete here itself. Everyone open packet tracer. Everyone open packet tracer now. Everyone has open packet tracer. Do one thing. Just take six pieces from here. Six pieces. Okay. Now there is something called hub over here. Take this hub. Just connect this. See now, when trying to connect and do one thing, just press Control key and then press this. Press Control key and press this. So what will happen? You don't have to connect again and again. See, just click, connect. As much as connectivity you want to establish, you can do it. As much as connectivity you want to make, you can do it. Everyone has done this. Please confirm in the chat box. If everyone has done this, please confirm in the chat box. If everyone is ready with their lab, please confirm in the chat box. Okay, what about others? Everyone lab is ready. So what we have done is we have built up the hub over here. It is not like today we are learning about today we are only using routers and switches. It is not like these are the first devices. Okay, before switches we were having bridges, we were having hubs, but as the time goes on, technology improve, the changes come, the improvement come, the things started to become obsolete due to their limitations. But now we will understand from the beginning one by one. Now this is something, let's say for example, in olden days you were supposed to build up a network. First floor network is there, second floor network is there, third floor network is there. It was using a hub. Now what is the problem over here? Let's understand. And before that, now let's say this is something your network which you have built up on the hubs. Now this network is built up, and now let's say for example this PC1 wants to talk to PC0. Okay, and this is connected to this hub. Now let's do one thing, take the packet from here and say that PC0 wants to communicate to PC1. Come to simulation over here. Come to, okay, sorry, we have not configured the IP address. Let's do one thing, first configure IP addresses on all the PCs. Come to PC0. Okay, and start configuring the IP address one by one. 192.168.1.1, or else don't do 1.10. 192.168.1.10. Then come over here and give the IP address 192.168.1.20. Give the IP address similarly over here 192.168.1.30. Give the IP over here 1.40. Give the IP address for all the computers in your network which you have configured. Now, now just do one thing. Take a simple PDU from here, okay, and give it over here to PC0 to PC1 and start your simulation from here and play. See, PC0 is trying to communicate to PC1, everything is going fine. Now, at the same time, again one more PDU and give to PC1 to PC2. Now, one thing what you will observe is, see, when PC0 was communicating to PC1, right? When PC0 was communicating to PC1, this is communicating from this hub. But you can see that when the broadcast come to hub 0, it is sent all the hub. It is sent to this hub. You can see the broadcast is sent over here. Then the broadcast is sent over here also, which means that hub is a single broadcast domain device. Which means that if you have 100 hubs in your network, if the broadcast is received on one device, it will be forwarded to all the devices. And you can see over here, right, the PC0 want to communicate to PC1, the broadcast is received over here, and then the same broadcast is comes over here, and then you can see over here also broadcast message, here also broadcast message, meaning that it is a single broadcast domain. But the problem with the hub is, it the problem with the hub is, it is a single broadcast domain, that is fine. But again, the two PCs cannot communicate. Why? Because it works on single duplex. It works on single duplex. What is single duplex? Anyone? Please, can anyone say what is single duplex? Yes, anyone? Not single duplex, half duplex. Sorry, it works on half duplex, meaning that half duplex, meaning that one-way communication. Meaning that at a time only one PC can communicate to another. Now we have put that PC1 also want to communicate to PC2. We have put this, right. Now we said that, okay boss, at the same time I want PC1 to also communicate to PC0, and let's see what is going to happen. Now see over here, PC1 also want to communicate to PC2 over here. You can see one more thing over here. See, the communication is happening over here, but the broadcast is reaching till here. Although these PCs are denying, because this broadcast was not meant for them. The destination IP doesn't match. All of them has denied. But the problem is the complete network is broadcasted, right? Each and every device is getting unnecessary broadcast request. Now, now see over here. PC0 was communicating to PC1. Everything was fine, but PC1 tried to communicate to PC0. The over here you can see the collision is started. There is a collision over here. Why? Because it is a half duplex device. At a time only one device can communicate to another. And not only that, this collision, let's see what happens further. Now see, the same collision which was here is being forwarded here also. You can see the collision over here also on this hub also. Let's see what goes ahead. See, the same collision. This is how the collision is represented in packet tracer. The collision packet comes over here also. See, on this hub, the same collision happens over here also. Meaning that the hub is a single collision domain device. Is it clear? So the problem was with the hub was it was a single broadcast domain. Whatever, uh, even the one PC want to communicate to PC2, if there are 100 PCs, everyone will get that broadcast packet, and it is a one-way communication. It is a half duplex communication, meaning that at a time only one PC can communicate. If another PC try to communicate, there will be a collision, and the same collision will be forwarded to another hubs, and there will be a complete collision in the network. So this is the reason hub was not a better choice, and hub is no more used now. Then another thing which come, anyone can tell what was another thing after the hub? Another thing that come was bridge. Now let's see. We will remove this hub and we will put bridge, and we will see how it works. Over here, you can just click this and delete the hub from here. Delete. Now there is something over here called bridge. There should be there. On switches over here you will find bridge. Yes, this is a bridge. Now the limitation with the bridge is limited ports. Let's see. We will connect this. See, no available ports. Only two ports are available. It's okay. We will only connect this. We'll leave this apart. Everyone has connected. It will take some time to come up. Why this time is taken? This everything we'll discuss. Don't worry. So everyone has understood, right, why we are not using hub. The reason is very simple, that it neither breaks a collision domain nor a broadcast domain. That is, hub is neither it doesn't separate the collision. Whatever is received, it will just forward to everyone. All other hubs also, all other ports also. If the collision is detected on one port, that the same collision will be forwarded to all other ports. And it is a single broadcast domain also. Now, now we have a bridge over here. Now, over here, over here, let's say PC1 wants to communicate to PC. Okay, now this PC0 started to communicate with PC1. Or what is the name over here? PC0, PC1. Okay, see, see over here, PC0 want to communicate to PC1. It is broadcasted. The broadcast comes to hub, and the same broadcast is forwarded over here on bridge. One second. Let me check why this port is not coming up. Hold on. Yeah, okay, it's done. Now see, broadcast comes over here, and then the same broadcast is sent over here. See, on hub 1 also, broadcast is sent over here also, and this then PC2 and this PC3 also receive. They will reject it. Why? Because this was not meant for them. Moving ahead, let's say now at the same time, this both PCs also want to communicate the, at the same time. Both PCs want to communicate at the same time. Let's see what is going to happen. See over here, there is a collision, right? The collision is there on hub. Now let's see what happens further. See now, same collision comes to bridge. Okay, the collision was there. This collision was forwarded on the bridge also. Now let's see what happens further. Whether the bridge forwards the same collision or no. Did you find any collision on hub 1 over here? There is no collision packet. Just concentrate over here. Did you find any collision over here? There should not be any collision coming over here. There will be no collision. See, there is no collision. Why? Because bridge has per port collision, meaning that if there is some collision detected on a specific port, the same collision will not be forwarded further. It will just drop that collision. But broadcast, yes, whatever broadcast packet it will receive on one port, it will forward it to another port. But it will never forward the collision because it is per port collision domain. But when you talk about the hub, it is per collision domain, meaning that whatever collision is received on one port, it will be forwarded to all other port. But in bridge, that is not the case. Whatever collision is received on one port, that will be dropped over here rather than forwarding it to another port. But in broadcast packet received on one bridge, it will be forwarded to another bridge. Is it clear? Any questions and doubt over here? But the limitation, and one more thing, the bridge has the capability of maintaining the MAC table like switch. But the limitation was, one of the limitation was limited port numbers, and another thing was, in bridge there was no possibility of breaking down the domain. If in case broadcast domain, if in case, let's say for example you have 100 of bridges in the network, and there is a broadcast on one of the bridge, that the same broadcast will be broadcasted to all other bridges, which will create unnecessary traffic flow. So that was the reason bridge was not considered a feasible choice. And then thereafter comes the switch. Now we will just do one thing. We will be deleting this. Delete it. So then thereafter comes the switches. From here, just take one switch, okay, and connect the switches. Control and press this again. Connect the switches. Everyone has connected the switch. Everyone has connected the switch. Let me delete this. Okay. We have already checked the simulation. Similarly, you can check it over here also. But let me tell you something. Again, switch is something port collision, meaning that if you try to just ping the packet from here to here, if a hub there is a collision over here, the hub, as usual behavior, will be forwarding the collision over here on the switch. But when the switch receives the collision on one port, that collision will not be forwarded to another port, meaning that if there is a collision on hub 0 and the switch is there in between, collision will not be forwarded to hub 1 and hub 2. Another thing is, if a broadcast packet comes on one port, then the switch will be broadcasting it to another ports. But again, the switch is something smarter device than bridge, and the broadcast can be broken. How it is broken, we will see in some time. But yes, switch is capable of breaking the broadcast, not directly, but using some configurations. And then the last part is a router. So a router is something per port collision domain. A router not only breaks the collision, but the router is capable of breaking the broadcast also. So summarizing the things, what we can say, what we can say about hub, router, switches is, when you talk about hub, works on half duplex, meaning only one way communication is possible. Then it is single collision domain, single broadcast domain. Right? Then when you talk about bridge, full duplex, airport collision, single broadcast domain. When you talk about switches, full duplex, per port collision, and single broadcast domain, but it can be changed and switch ports can be in different broadcast domain. Can configure switch ports in different broadcast domain. Router, it not only breaks collision domain but also breaks broadcast domain. Now, if there is a router, so it is never possible that a broadcast from one network will pass to another network. How we will see in the practicals, don't worry about this. Any questions, any doubts over here on collision domain and broadcast domain? Okay, let's take a break for 5 minutes and then we will be continuing and we will understand the different type of modes. We will start doing practicals on switches first, and whatever the practical parts are there, we will cover that. And we'll before that we'll understand the different type of modes on the Cisco devices. Let's take a break for 5 minutes and then we'll continue. Don't leave the meeting. We will be starting with the switching first and then we will be coming to the routing part. And in the beginning, as I told you, that the name of this series is CCNA, but we are going to learn something beyond CCNA, a very advanced lab also, which will cover your CCNP content as well. So before we move ahead, when I talk about the modes, so it is not like a router or switch. The operational mode, whether it is a router or a switch or any other Cisco devices, this modes you will see in every devices. So what are those modes? See, primarily there are three modes, but in total there are five modes. Let's understand one by one. First mode is user execution mode. Another one is privileged mode, global configuration mode. These are the primarily modes which you will be going and doing the configuration on daily basis. Then there is something called interface configuration mode, and there is something called Roman mode. let's understand this one by one. What are these modes? We will understand one by one. Everyone has the packet tracer open with them, right? Now, just open the packet tracer over here, and we will just take the same switch. We'll take the same switch, which is over here. You can see. Just double click over here. Click on CLI. Click on CLI. Everyone is there on this page. Now, as soon as the devices come up, just press enter over here, and you press the enter, you will see that the prompt has come up with this sign, with, you can see this type of sign over here also, right? See, this greater than sign. This sign indicates that you are in the user execution mode. You are into user execution mode, and this mode has a very limited commands working. That is something, monitoring commands, I can say, are working on this mode. If you want to see which more commands are working, just press question mark over here. See question mark, and this will come. These are execution, user execution commands. These commands will work over here. Connect. Then you have disable to turn off the privilege mode. Then enable is there if you want to go into the next mode. Privilege mode we have said. Now if you want to go to the next mode, enable is there. Then exit is there. Exit means you will be exited from here. Just click on exit, you will be exited from the, see, hit enter again, you comes over here, question mark to see which all commands work. Then there are some show commands. If you click on show over here, and you don't have to type full command, if you just give the first two letters and press on tab button, automatically it will come. After show, then press the question mark again, and you will see that this all commands will work on the user execution mode. You can check the ARP table in this mode. You can check the CDP information, clock, see, show ARP, sorry, put show ARP. It will give the ARP details if it is available with the switch. Then if you give show CDP, it will give you the CDP details. Show interfaces, it will give you the interface detail, all the interface details it will give you. So similarly, you can see how many commands are working on this. MAC address table detail, it will give you. So MAC address table, it is giving you the MAC address table details. See, on fast Ethernet 2, it has learned dynamic entries. So all these commands which you can see is being executed on user execution mode. There are limited commands, I can say. There are limited commands which works on this mode. Now there is another mode called as privilege mode, right? Privilege mode. Now if you want to go to this mode, see, if you want to give the monitoring access, like if you have a level 1 team who is doing a monitoring, at that time there are levels of team, right? Level 1 who is basically doing a monitoring job, level 2 is there who is doing a limited configuration, level 3 team is there who is doing the advanced configuration and responsible for end to end network stability and all. So you know that level 1 has a very limited knowledge, and there is a possibility they will do mistakes if they are given the configurations access and all. So for the monitoring purpose, they can do this monitoring, right? The interface is up or not, clock is working fine or not, the MAC address entries are there, or IP address details, and all this can works on the user execution mode, and they are given this kind of access. Now, if you want to go to privilege mode, then what you have to type is enable. Just type en and press tab button, it will take enable. Okay, if you type enable, there are levels. What is this level? I will explain you what are these levels and all in the coming time, but for now simply say enable and hit enter over here. You will see that as we type enable in the user execution mode, we enter into privilege mode, right? privilege mode. Over here, there are many things. Many commands will work over here, which we cannot work in user execution mode, but those command will work over here. And remember, every another mode have, if there is another mode, the previous mode command will work over here. Meaning that in privilege mode, user execution command will work, but in user execution mode, privilege command will not work. Okay, the high level command will not work in low level, but whatever commands are working on the low level will work on the high level as well. Whatever commands are working in the user execution mode, the same will work over here in privilege mode also. Now show r command, we have seen that was working there, it is working here also. If you see show mac address table, that command was working there, that is working here also. But over there you will see one thing. If you will see over here, there was nothing like to see the configuration. If you want to see the configuration of the switch, you cannot see, there is nothing like to see the configuration. But over here, if you will see, just put show and put question mark, and you will see there is a huge list comparative to user execution mode. There is a huge list of commands working over here, right? Now if you want to see the configuration of the switch, show running config and hit enter. It will give you the complete configuration of the switch. This you cannot run on the user execution mode. Right or wrong? Now the question might come to someone's mind that I was saying that user execution access is given to level 1, privilege access is given to level 2 and level 3. But as soon as I type the enable command on the user execution, you are coming to privilege mode, right? So how you will control this? Don't worry about this. If the question has come to your mind, you are a smart student, and if it has not come to your mind, then you have to learn more. So remember, not learn more, you have to think wisely. Remember, there is something called the enable password. Also you can set over here. Before coming to privilege mode, you can set up a password for the privilege mode. Coming to privilege mode, there will be one password set. So how to set the password, this we will learn in the coming time. But for now, just remember that there is a mode, user execution mode, which we have discussed. Then there is something called privilege mode, that also we have discussed. Now coming to privilege mode. Now see, remember one thing I told, that that greater than sign mark is something how you will recognize user execution mode. Privilege mode using hash sign. Okay, now I put it over here. Privilege mode using this. Now the third mode is configuration mode, global configuration mode. As you type configure terminal, just type conf and press tab. Key tab configure terminal. As we type configure terminal, over here we will enter into global configuration mode. Now the commands which you enter over here are basically used to configure your switch, global commands. And whatever changes you will do over here will be seen in the running configuration. Over here you have given show running configuration, right? Whatever command you will give over here will be reflected, will be seen in show running configuration. Whatever changes you do, now if you want to do, if you want to see whether the changes are done or not done, then in that case you will be able to see those changes. Now just press control. See, now if you want to move from one mode to another mode, one is exit. We have seen exit, right? Exit. If you give exit, this will take you one mode back. And there is something called control Z. From control Z also you can come, either control Z or exit. Okay, now over here, just give the command in privilege mode, give the command show running config and hit enter. You are able to see that the host name is switch, right? The host name everyone know, the name of the switch is switch. Just press control Z, stop this remaining part. Okay, now come to the configuration mode. Type conf t. Shortcut will also, it will take shortcut also. Conf t means configure terminal. Hit enter. Now change the host name. Give the command host name. You type host and press tab button. It will take you to host name. And give the name whatever you want. I will say my lab. One more thing, you will see the host name. It is seen over here, right? Switch. Here also, it is switch now. The host name is switch. We have seen the host name is switch. And you can see the switch over here. It is a host name. Now you give the command host name my lab. You are changing the host name. You are changing the name of the switch. Hit enter. See, the name is changed to my lab. Give the command exit. And now give the command show running config. Hit enter. See the changes. Host name is shown over here as my lab. Everyone can see this. Now, how to set the password for moving from privilege user execution mode to privilege mode, so that the level 1 guys will not access the privilege mode, that we will see in the coming time. But for now, have you understood user execution mode, privilege mode, global configuration mode? Everything you understood, right? Okay, that's good. Now, if you want to enter to interface configuration mode, so what you have to do, first you have to go to configuration mode. Okay, one more thing, you can check the interface details also. So what is the command to check the interface details? Show, you can say sh, or I will type show ip interface int brief br, or br tab, it will take full. Show ip interface brief, and it will give you the interface details. See, show ip interface details. It is giving you the complete interface on the switches. Show ip interface brief is the command to check the interface of the switch or a router or any other Cisco device. Show ip interface brief. Now 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 just say configure terminal, and we will enter into one of the interface. So type int for interface. Fast Ethernet, the shortcut is FA. If you type this also, you can enter FA 0 by 1. FA 0 by 1. Hit enter. Now you are into configuration interface mode. But before that, let me write down for you over here. Global configuration mode means CONF. This is how your configuration mode looks like, and this is how, one second, this one, configuration interface mode. This also will write down over here. This is your configuration interface mode looks like. Sorry, IF, it is IF, not INT, IF. So you have entered into configuration interface mode. If you give the command exit, it will take you one mode back. Okay. Now, if you want, instead of fast Ethernet, you have given FA. If you want to go to Giga Ethernet, you will give Giga Ethernet port. See, INT GI, and the port number is 0 by 1. Now, you have given the command exit. It has taken you one mode back from configuration interface mode. It has taken you to configuration mode. But over here, if you press Control Z, it will take you to privilege mode directly. Control Z. See, it has taken you to the privilege mode directly. It didn't take you one mode back, right? Now, please again come to this configuration mode. Please come to configuration mode, mode again. Go to interface mode, INTFA 0/1. Now you are into interface configuration mode. So, as the name implies, interface configuration. So, over here in this mode, what you can do, you can configure the interfaces. If you want to give the IP address in switching, of course, you will not give the IP address in switches. That we'll discuss. How you can give the IP address if required on the switches. This all thing is again coming in the practicals in tomorrow's lecture. But if you want to do any kind of configuration on your interface, now let's say for example you want to give the description of this interface. So you can say that you can give the description. This is my LAN port, for example. You have given the description. This is my LAN port, and and this description you can see. This is nothing but the interface configuration mode where you can do the configuration of your interface. Now, if you want to see the detail of this interface, na FA0/1, for example, just press Ctrl Z, come to the privilege mode and give the command show interface FA0/1. FA0/1. Show interface fast Ethernet 0/1. Hit enter. You will see the complete details of this fast Ethernet 0/1. You remember you have given the description. See, the description is there. Just recently we have configured, right, in the interface configuration mode. This description you can see. What it says is that interface gives you the detail that fast Ethernet 0/1 is up, line protocol is up. Why it is up? Now see, we have connected now. If you just take this cursor here, it will give you the details that it is connected to FA0/1. One interface will be connected. Which interface is connected? This one, the middle one. Fast Ethernet 0/1 is connected to this one. It is giving you the details for that. It is up. The line protocol is up. It gives you the MAC address of the port number. It gives you the description. What is the bandwidth, reliability. What is loopback? We'll discuss later. So complete details. How many packets are being sent? How many you received? Each and everything is given over here. The complete detail about this interface you will see using the command show interface and the interface name. Any questions? Any doubt over here? Now, let's say for example you want to make this interface down. For example, you go to configuration, you go to interface FA 0/1 and say shutdown, shutdown. It will shut down the interface. Now, one more thing, as I told you that the commands which are working in the previous mode will work over here also. But when you talk about if you want to run the command of privilege mode into another mode, like into configuration mode or into interface configuration mode, you can do, but there is something you need to add. Now let's say, what was the command to check the interface detail? It was show interface FA0/1, right? If you hit enter, it will not work. Why? Because this, you are into interface configuration mode. But if you want to check the output over here, what you can do, just say do show interface FA0/1 and hit enter. It will give you. Now I want to ask you, show you something. Similarly, give the command as show interface FA0/4. Now see the difference. When you give the command FA0/1, it says that FA0/1 is administratively down. And you know that in your network you have only connected first three ports, FA 0 by 1, FA 0 by 2, and FA 0 by 3. Have you connected 0 by 4? No. So it is saying FA 0 by 4 is down. FA 0 by 4 is down. But over here it is saying administrative down. What is the difference? See, you went to FA 0 by 1 and you have given the shutdown command. You being an administrator, you have made the port shutdown. That's why it is saying administrative down. But over here, the cable is not connected. The physical connectivity is not there. That's why it is down. You understood the difference? That's the difference. You made this administrative down, and being administrative, you made down. So it is saying administrative down. And this is something, it is not physically connected. So it is down. Now, again, if you want to make that port up, simply say no shut and check now. Show interface FA 0 by 1. It has come up. You give the command do show IP interface brief. It shows up, up, up. This is down, down. It is not connected. Again, make it down and give the command. See now, if you want to use the previous command, just click on up arrow key. Huh? Automatically, all the commands will come. See, if the command do show IP interface brief, it says administrative down. Why? Because you made it down. Again, give the command no shut because you are into the interface configuration mode of FA 0 by 1. Now again check. It is up. Any questions? Any doubt over here? And the last one is a Roman mode, right? Roam on mode. So we can enter into this Roman mode when we interrupt the boot process. Now let's say for example your router or a switch or any Cisco devices is booting up. At that time, what you will do, you will interrupt the boot process. So this is nothing but a Roman mode. Generally, we enter in this mode for password recovery or if you want to back up your iOS at that time. How you enter? By interrupting boot process. You interrupt the boot process, you enter into this mode. And why? To recover password, backup iOS and all. It is something, it is something like, it is like the BIOS mode of a PC. Any questions, any doubt over here on the modes? Allah says that the screen comes black, so she has done some R&D. That's good, Allah. Oh, this one, this was all about the user modes in Cisco devices, whether it is router or a switch or any other appliance or even a firewall from the Cisco. These are the different type of modes you can see where you can do a configuration, where you can do a monitoring, and where you can see the outputs of the commands. Any questions, any doubts over here on the different type of modes? If you have any questions, any doubt, please put in the chat box. Just close it, close the packet tracer, open the new lab. I'll just delete this. Okay. we have learned that when we talk about switch, it is per port collision domain, and it's a single domain device, right? Meaning that on switches, just take one switch over from here. This is one switch, and this switch has so many ports, right? Now, if there is a collision detected on one of the port, what is going to happen? That collision will not be forwarded to another port because it is per port collision. But when you talk about broadcast, in that scenario, what is going to happen? What is going to happen is the broadcast received on one port will be forwarded to all other port. This is what we have discussed. Now, just consider you have a network over here, and then to this network, you have like PC is connected, PC is connected, and over here also PC is connected. Then you have again you have some more PCs over here connected to some other switch. Over here you have PCs. Over here you have PCs. Then you have one more switch over here. Then let's say for example you have this switch connected. Assume that this is something a network, and this is something only 336 devices are connected. In your network you will be having thousands of devices connected to a network, right? So what I told is whatever the switch is single broadcast domain. So if in case the PC8 over here want to talk to PC11 over here, PC8 wants to talk to PC11 over here, just do one thing. PC8 wants to talk to PC11 over here, but no function. Okay, fine. You have to configure the IP address. Let's do one thing. We will be configuring the IP addresses over here. 192.168.1.10, and over here 192.168.10.20. Sorry, make it 10.10, 10.20. Okay. Now PC8 want to talk to PC11, right? This is PC8, PC11. See now over here, PC8 sends the request over here. Request comes to the switch, the ARP request. See, the type is ARP, right? If PC8 wants to talk to PC11, first it will send the ARP request to learn the MAC address. The ARP request is received on switch 11. Now what happens? Just see. What switch has done? Switch has forwarded the ARP another switch at the same time to the PCs connected over here, which means that what is the ARP request? It is a broadcast request. ARP request is a broadcast request. ARP request is the broadcast request. Now it comes over here. PC. What will happen when the ARP request is sent? What is there? The message contains source IP, source MAC, destination IP, destination MAC is blank. Destination MAC is blank. Receives on PC6. PC6 checks the destination IP. Oh, it is not for me. PC7, it's not for me. Similarly, it is forwarded to another switch from this port. This switch forward further. All of them checks. It is received over here. PC9, PC10 discarded. This it was not for them. PC11 didn't discard it. See, now what happens further? Now see, everyone has discarded. Now PC11 has sent one message. What is this? It is a ARP reply. and you can see that it is unicast. Now PC11 has sent it to switch. Now what switch does, we'll see further. See, switch has sent this packet straight away over here. It didn't broadcast it. It is a unicast packet. A unicast is 1 to 1. So PC11 has sent over here, but it didn't send this packet on PC9 and PC10. Why? Because it is not a broadcast message. It is a unicast message. So it is sent over here on the switch, and over here on the switch, this packet has come over here. See? Now let's see what happens further. Now this switch has forwarded the packet to this PC8, which is unicast. When it was the PC8 want to talk to PC11, what it does, ARP request. It first it would have checked in ARP cache. It was not there. It sent the ARP request. ARP request was ARP request was was broadcasted. Broadcast packet came to switch. Switch has broadcasted further all its port. PC6 discarded, PC7 discarded, went forward to this switch. Then this switch again further broadcasted all its ports. PC9 denied, PC10 dropped. Then on PC11 it says that, oh, this is a destination IP, it has come for me. Then it has prepared the ARP response or ARP reply, you can say. But when the ARP request was there, it was broadcasted, because ARP request is a broadcast packet. But when the ARP reply or ARP response was given, it was a unicast packet, and that it came to the port where it is connected on the switch. Then that switch has forwarded to this switch, and then this switch, because what happened when the PC8 has sent the broadcast request, this switch in its MAC table has updated the entry saying that on this specific port, this MAC address I have learned, and then this has forwarded further. Now when the reply came from this switch to this switch knows that this MAC address is connected, the PC head is connected on this port number. It has given the reply, and you can see the PC head has learned the MAC address of PC11, and now the communication has started over here, and you can see the next packet is ICMP. The ARP process is completed. Now PC8 and PC11 both in their both caches has the MAC entries, and now this packet is ICMP packet. You can see it's an ICMP packet. Now the ping has started. See, and this is not broadcast. This is unicast 1 to 1. See the flow. The PC11 will reply back. See, it is replying back. It's ICMP packet. PC11 packet reply. It comes to switch 2 now. Now it will go to PC8. Success. You can see it's successful. Source is PC8. Destination is PC11. ICMP is successful. Now you might be thinking, what is this? This is something DTP and all DTP, BPD, this everything we learn. Just forget this for now. Is it clear? Now my main reason for explaining this is, just see now, this was hardly three pieces over here, two switches, and for one request there was so much flooding. Just imagine if you have hundred of switches in the network and thousand of hosts, thousand of PCs and other networking devices connected, and if one PC want to talk to another PC, how much broadcast will happen? Right or wrong? How much broadcast will happen? So do you think that if PC8 want to talk to PC11, this broadcast should be flooded to each and every? Now let's assume there is one more switch. You have, let's say for example, one more switch over here, then you have one more switch over here also. Do you really think that all the broadcast should go to all the devices, all the switches, all the network? Is it really required? The answer is no. If PC8 want to talk to PC11, why this unnecessary broadcast should go to another switches as well? It is not required, to be very honest, right? So in switches, as I told you, the difference between the bridge and the difference between the switches, that manually you can break the broadcast. So what you can do is you can manage it and you can break this unnecessary broadcast, and that breaking of those broadcasts is possible using a concept called VLAN. What is the concept? VLAN. It is VLAN. Using VLANs, you can break this broadcast. Using VLAN, you can break this broadcast. VLAN stands for virtual LAN, means creating the LAN inside the LAN virtually. So using VLAN concept, you can divide the device logically. Now this is one switch. Now, if there is one switch, you can divide the device logically. Meaning this specific switch, you can divide this device logically, and then with once you divide it, it is possible that if there are so many ports over here, now there are around 24 ports, you can say that this first 12 ports, first 6 ports, 4 ports, you can divide, and you can make it possible that the broadcast from one device cannot go to another device within the switch. And this is how you will logically divide the device to break this unnecessary broadcast. And dividing the switches to break the broadcast is nothing but a concept of VLAN. See, if it is router, I have said you that router is not router breaks the broadcast. It doesn't allow the broadcast, if received, to be forwarded further. It will not allow the broadcast. But in switches, broadcast is there. So whatever is received on one device will be forwarded to all other devices. But you can make it possible that you can reduce the broadcast, unnecessary broadcast, using a concept called VLAN. Now, what is VLAN? How to break this broadcast? Everything we'll understand in tomorrow's lecture. So I think it's the right time to take a break over here and to be continued tomorrow. Any questions, any doubt over here, please feel free to ask. You understood why exactly the VLAN is required, the basic functionality, something you have come to the mind, right? If there are no questions, then we will meet tomorrow.